From Earth to Proxima Centauri in 20 years? The Project Breakthrough Starshot. In 2016, the La Silla Observatory in Chile identified Proxima b, the closest exoplanet known to us today. It orbits in the habitable belt of its own star, Proxima Centauri, a red dwarf located 4.2 light-years away from us, in the direction of the Centaurus constellation. Proxima Centauri is part of the Alpha Centauri system, a triple system consisting of a yellow dwarf and an orange dwarf very close to each other and from Proxima. Proxima is a red dwarf, probably the most widespread stellar type in the Milky Way, dim and relatively cold. It's a little more than the age of the Sun, about 4.8 billion years, but a diameter that is only 15% that of the Sun and a surface temperature of only 2,725 degrees Celsius, compared to 5,725 degrees Celsius of our star. Consequently, its habitable zone, that is the circumstellar belt in which a planet could have liquid water on the surface, is very close. It is located about 1/20th of the Earth's distance from the Sun. For example, Proxima b, which with an orbital period of 11.2 Earth days is within this zone, would be a hot world if it was around the Sun. Even if located inside the habitability belt, it is by no means certain that Proxima b is actually habitable, due to the intense activity of its star Proxima. In fact, red dwarfs are known to manifest sudden and random flares, even very powerful ones. Flares are violent eruptions of matter that explode from a star's photosphere, releasing large amounts of energy. They are often accompanied by large plasma ejections known as coronal mass ejections. These elements determine the space meteorology of the system and have a fundamental role in the habitability of a planet and the eventual evolution of life on it as we know it. Under extreme conditions, superflares could wipe out a planetary atmosphere and lash a magnetosphere heavily, pushing it back until it leaves the planet's surface exposed to deadly radiation. According to statistics, it is estimated that Proxima Centauri produces flares of this magnitude at least 5 times a year. Every scope, a series of small telescopes that observed the stars in the southern hemisphere, detected a superflare that made Proxima 70 times brighter in 2016. Again, a very intense flare by Proxima Centauri was registered on March 24, 2017. The brightness of the star increased by 1,000 times in only 10 seconds. The brightness increase was so big that Proxima became visible to the unaided eye for a short period. Given these premises, if there was an atmosphere around Proxima b, it probably didn't survive the likely activity of Proxima, while on our planet the ozone layer absorbs harmful ultraviolet radiation. On Proxima b, assuming it has no magnetic field, 90% of the atmospheric ozone would be lost after only 5 years of stellar activity. The results of several simulations carried out by a team of researchers led by Christophe Lovis of the Astronomy Department of the University of Geneva showed that without ozone, the surface of Proxima b would be devoid of protection against UV rays. During superflares, such as those observed, the radiation dose without protective ozone would be 65 times greater than that needed to kill 90% of the most resistant organisms to ultraviolet rays on Earth. Despite these features, would you like to visit Proxima b? Let us know in the comments. But what do we know about Proxima b today? It's probably a rocky planet whose minimum mass could only be 1.17 Earth masses. This value, together with other estimates, brings it to 6th position in the list of exoplanets that are most likely to have a rocky composition and keep liquid water on the surface, with Earth Similarity Index, ESI, equal to 0.87. This value classifies alien worlds based on their similarity to the Earth, as a function of radius, density, escape velocity, and temperature, but does not take into account all the factors that could affect their habitability. In any case, we still know little about Proxima b. Its orbital inclination is not known, as well as its exact radius, and therefore also the mass could vary considerably. This means that the planet might be rocky like the Earth or frozen like Neptune with a thick atmosphere of hydrogen and helium. Although Proxima b is about 20 times closer to its star than Earth is to the Sun, it receives comparable energy. This means that the surface temperature could favor the presence of water in a liquid state, if there is any, and support the development of life. However, it is likely that the planet is stuck in synchronous rotation due to the tight orbit around its star. That is to say, it always shows the same face to PROXIMA as the Moon does to the Earth. An important dichotomy between the two hemispheres could arise from this feature while the entire planet is bombarded by the energy activity of the red dwarf, receiving an estimated amount of X-rays about 400 times greater than that which the Earth receives from the Sun. Nonetheless, the Proxima Centauri system remains one of the most intriguing to study and one of the most coveted for future extrasolar exploration. The planetary system of Proxima Centauri has inspired several projects. Among the best known, the Breakthrough Starshot, also born from the Breakthrough Initiatives. Starshot is a research and engineering project announced in 2016 and born to develop a fleet of sailing interstellar probes and laser propulsion. It was founded by Yuri Milner, Stephen Hawking, and Mark Zuckerberg. In 2017, NASA also proposed a probe to look for biosignatures on the planets around the stars of the Alpha Centauri system. The launch, taking place by 2069, would celebrate the 100th anniversary of the Apollo 11 mission. Be sure to join the channel, leave us a like, and click on the bell. You will help us to make products of even higher quality. Another idea to study Proxima b more closely is the Starshot concept. It involves the launch of a mothership that transports small spacecraft a few centimeters in size to the outside of Earth's orbit. From here, a laser beam coming from the ground will accelerate the 4x4 meter sails connected to the microprobes up to 100 kilometers per second to the power of 2. Thanks to these probes, it will be possible to reach and visit the planet Proxima Centauri b in about 30 years and capture an image of high quality sufficient to fully understand the surface characteristics of the planet. A swarm of about 1,000 units is assumed to compensate for the losses caused by interstellar dust collisions while navigating to the planet of interest. In a recent detailed study, astrophysicist Chai Thiam Hong and his collaborators found that mitigating collisions with dust, hydrogen, and cosmic rays may not be as serious an engineering problem as one might think. Using our current technology, a trip to Proxima Centauri for a probe with the same characteristics as the New Horizons, the probe that recently visited Pluto, Ultima Thule, and is now entering the Kuiper Belt, would take about 78,000 years. But projects like Breakthrough Starshot or similar would give a big boost to the development of new methods of space propulsion and new technology for miniaturization of cameras and other electronic components, because it is certainly cool to travel to infinity and beyond, as Buzz Lightyear said in the Disney movie Toy Story, but it is equally so to look for applications that are unthinkable today, useful for improving daily life. What if one day you want to send a human crew to explore Proxima Centauri b? In this case, the problems to be faced would increase dramatically. Some researchers have tried their hand by analyzing some of them. As for the timing, the theoretical speed data of the next Parker Solar Probe, launched on August 11, 2018, were used. It is expected that this will be able to reach a speed of about 724,000 kilometers per hour, or 0.067% of the speed of light. Only this data should make us think a lot. In fact, a simple mathematical calculation is enough to understand that a possible trip based on this technology of thrust could last about 6,300 years. In the event that it is decided to send a human expedition to Proxima Centauri b, it will be necessary to consider a substantial generational change to be hosted inside a spaceship designed for colonization. According to the researchers, the minimum number of humans to send would be 98 people, split equally between men and women. However, this may not be as accurate. To calculate it, the researchers used a type of Monte Carlo simulation called Heritage, which allows to identify the most likely scenario, obtaining it through the consideration of various iterations between the variables. Taking into consideration the natural and accidental deaths, infertility, and the increase in consanguinity, it turns out that the journey represents an unknown factor, especially in relation to its length. Then there would be a serious problem of crew sustenance in the long term, which would require a control in both directions of the berths, with restrictions based on the maximum number of the population, not to mention the energy problem. The most critical element of all is undoubtedly the creation of a habitat of a few cubic meters, in which astronauts should spend the rest of their lives. It would be impossible for them to even return to Earth. once the scientific exploration of Proxima b is finished, unless they radically increase the capacity of the spaceship nuclear reactor to supply energy. But this would most likely lead to exceeding the limits of size and mass useful for launch. If you were astronauts traveling to Proxima b, how would you feel at the thought that you will never return to Earth again? Let us know in the comments. In short, a crew of heroes would be needed for such a mission. The astronauts must be selected not only on the basis of technical, scientific preparation and physical skills, but above all on the basis of character skills. It takes exceptional people to leave the Earth knowing they cannot go back, ready to spend decades locked up in a flying box of a few cubic meters. Their solitude would be absolute. Moving away from the Earth, they would see the latency time continuously increase between the sending of a message and the arrival of the relative response, a time that would gradually expand to become whole years. How would you feel to wait so long for a response to your message to Earth? Write it in the comments. The effects on the human body of years spent in space are unknown. All the experiments carried out so far have been limited to a year or so spent in low Earth orbit aboard the International Space Station, as in the case of the experiment involving the astronaut twins Mark and Scott Kelly. We do not know what adaptations and above all what physical, cognitive, and psychological damage can affect human beings forced to remain in space for decades, locked up with a narrow environment without the Earth's gravity, without the possibility of having contact with other human beings, without direct exposure to sunlight, and without being able to breathe pure air. Furthermore, there is currently no prototype of a space capsule capable of creating an environment in which astronauts can live for long years. An environment equipped, for example, with artificial gravity, micro-greenhouses, or recreational facilities. It is very unlikely that something like this could be produced within a few years. Above all, it is very difficult, if not impossible, that a home for astronauts, the supplies to survive in space for decades, and the scientific instruments to explore new worlds can be crammed within the limits of space and mass that even a super rocket like the SpaceX Starship must comply. All this suggests that a manned interstellar journey will not be possible for at least 50 years, perhaps more. And even when it has finally become feasible, it won't be at the paltry cost of $100 million, but several tens of billions of dollars. Considering the preliminary decades spent on research and development, it will be an undertaking that only a strong international political will can transform into reality. Be sure to join the channel, leave us a like, and click on the bell. You will help us to make products of even higher quality.